Today we're going to be calculating amounts using mole ratios. So far we've just been covering analyzing, the amount in moles, mass, molar mass, um, you know, percent composition, all that stuff of specific compounds. But now we're moving on into the unit where we are now looking at chemical reactions. Okay, and how if you have so many moles of carbon dioxide, how does it affect the moles of oxygen and so forth? Okay, so I'm just going to teach you how to use mole ratios today, and it's supposed to be part of a bigger calculation next day. So this is the tricky part, so we want to just kind of go over this, and then we'll move on to some bigger stuff, make connections to the reaction equation. Okay, all right. So for the first one here, the reaction equation is already balanced. Okay, so all the formulas are written correctly, and they have been balanced with coefficients in the front. Okay, so the coefficients here, I want you to think of them as it's like a recipe, right? You're trying to create a chemical reaction equation, so you need to put in 6 carbon dioxide molecules. You need 6 water molecules, and then that will create the 1 glucose molecule and the 6 oxygen molecules. So this is the ratio that you need in order to create this ratio that comes out. Okay, so yeah, you can think of it as molecules. You can also think of these as, I guess, in dozens. Like you have 6 dozen of the carbon dioxide, 6 dozen of the water, and then that will make 1 dozen of the glucose and 6 dozen of the oxygen. Or you can think of it as moles. 6 moles of carbon dioxide, 6 moles of water will make 1 mole of glucose and 6 moles of oxygen. So that's the ratio that they will always form regardless of, I guess, what unit that you're using to measure, okay? So you could think of 6 cups, 1 cup, 6 cups, okay? And so forth. So taking that, we're going to look at it in the context of moles, okay, today. Okay, so we're going to take the mole ratio of carbon dioxide to water, so we're going to compare them. So we're going to assume here, the first one here, carbon dioxide, say we know some information about it, but we're trying to figure out some information about water here. So what you're going to do here is just write the compounds in a ratio form so we can compare them. So I'm just going to write CO2 to water like that, okay? So we're going to write the mole, the coefficients that they're in front of the compounds there. So 6 to 6, okay? So this is, again, can represent how many moles there are. So there's 6 moles of these, 6 moles of those. So we have a 6 to 6 ratio here. And we can reduce this like that. So again, think of it as like you're dividing it because you were trying to get, if we have 1 carbon dioxide, well, how many waters do we need? So if we just divide this one by 6 to get it to 1, we have to divide the other side by 6 to get it to 1. So we have a 1-to-1 ratio here. So if I put 1 carbon dioxide in, I need 1 water. So in this case, I needed 6 carbon dioxide and 6 waters. So now how we connect this to like actual amounts. So say you had like 5 moles of carbon dioxide. Okay, so if you had 5 moles of carbon dioxide, well, how many moles, like if you're putting 5 moles of carbon dioxide into the reaction, how many moles of water do you need? Well, it's a 1-to-1 ratio, so you need the same amount of water. Okay, so that's kind of what we're doing here. We're trying to compare just the amounts of each substance that we're looking at, and then if we know a lot of information about one, so for example here, the carbon dioxide, if I knew the information about carbon dioxide there, I could predict how much of the other stuff I would have, okay? Okay, so we'll look at the next one, B. This time I want to analyze the relationship between carbon dioxide and glucose, okay? So let's just set up the ratio and just lay it out so we can analyze it. So we have carbon dioxide to glucose. Okay, so the ratio, if you're taking a look at the coefficients in the balanced chemical equation, so see it has 6 carbon dioxides, and there's no number here, so it's 1, so 6-to-1 ratio. Okay, so if I dump in 6 carbon dioxides, react them with 6 waters, I will only get 1 glucose molecule forming. Okay, so that's how the recipe works. So now that you know the ratio here, it's 6-to-1. Okay, so what I want you to do here, so always try to reduce it. You don't have to, I guess, but it's always good to see like if there's only one of one thing, how many of the other is there? So there's 1 glucose to 6 carbon dioxides. Okay. All right. So now if we do an example like the one we did before, so say I had 5 moles of carbon dioxide again to start with. Okay, so again, the balanced chemical reaction equation, that's like the recipe. It's saying that, if you put in 6 carbon dioxides, you only get 1 glucose molecule. So if I put in 5 moles, okay, of carbon dioxide, how many moles of glucose will form? Okay, so what you're doing here is you're analyzing your ratio. And the one above was easy because it was 1-to-1. But if you look at the one over here, you are looking at, it goes from 6-to-1. So how did that happen? 6-to-1. So you will divide by 6, okay, to get to the 1 mole. So that's what you're doing here. So if you have 5 moles of carbon dioxide, you're going to have 1/6 of glucose. So you're going to take 5 and divide by 6, and you'll get this decimal number. But okay, 8333, etc. Okay, so of glucose. So again, if you have 6 carbon dioxides, you only get 1 glucose. So if you have 5 moles of carbon dioxide, you will have 0.83 moles of of glucose. Again, if you're still uncomfortable with the idea of moles, you can convert it to something like money in your head to kind of understand it better. So you can think of it like the relationship was for every $6 there'll be $1 of glucose, right? So say if we went down to $5 now, $5, so you only have 83 cents, $0.83 of glucose. So just kind of look at it that way as well, okay? So with the ratios, I'm always writing the one that I know information about first, okay? So just assume in these examples, if you see, nitrogen first, then that's the one we know information about. Hydrogen first, then we know about hydrogen and so forth, okay? All right, so looking at the first one here, we need to know the relationship between nitrogen and hydrogen, okay? So write out the ratio here. So again, once you get good at this, and you don't need to write out these steps and so forth. So we're looking at the nitrogen to hydrogen relationship here. So we have nitrogen, there's 1 of those, and hydrogen, there's 3. Okay. All right. So again, if we're going from 1 to 3, hopefully you can see that you've tripled. Okay. So if I write an example here, I don't know, let's say again we have 5 moles of nitrogen to start with. Okay, so if you know the ratio is 1 to 3, so if I put in 1 nitrogen, I need 3 hydrogens. So if I put in 5 moles of nitrogen, because remember we can compare things in moles, okay? So 5 moles of nitrogen, that means I need 3 times this. So 15 moles of hydrogen. It was nice because it was a 1 to something ratio. Okay, so it's nice when one of the compounds is 1. Okay, but in this next example here, we are not going to see that. We're going to see that we're going to have hydrogen to ammonia. So you're going to see a 3 to 2 ratio. Okay, so it's a little tricky here now because it's like, okay, so Here, when I had 5, I just knew I could triple it. The other ones above, I just multiplied by 6 or doubled it or divided it by 2. But when it's a 3 to 2, this is when it gets tricky and you're thinking, okay, how does this work? Okay. All right, so we're going to assume here again, the first one, we know hydrogen. We know information about hydrogen. So let's just write that in here. Okay, so let's make an example here. So say we know, I don't know, like it's 2 moles of hydrogen. Okay, so we know that for sure. We're trying to figure out how much ammonia is going to form. So if I know that there's 2 moles of hydrogen involved in this reaction equation, how much the ammonia will form. Okay, right now it's the recipe saying it's a 3 to 2 ratio. So how do you figure that out? Okay, how do we figure out if there's 2 moles of this, how much of that? So what I want you to do here is I want you to, again, it was easier above here when one of them was 1. So that's what you need to do. You just need to get the one that you know. So we know hydrogen, okay? We need to get this one to 1. So if we're to do that, how do I get 3 to 1? Well, to get 3 to 1, I need to divide by 3. Okay, and if I do that, I have to divide the other side by 3. So when I do that, I get 1 to a 2 over 3 ratio, like that. Okay. Okay, so now that you see that it's a 1 to 2 over 3 ratio, you hopefully can see that you are now, if you're trying to find, if you know there's 2 moles of hydrogen, if you know there's 2 moles of hydrogen, the relationship is if I have one of these, I have 2/3 of the other one. Okay, so you can think of this as like 0.67 of the other one. Okay, so if you have $1, you only have 67 cents of the other one. So we always look to see, okay, we're going this way. So what did we do? We have to multiply by 2 over 3 to get to here. Okay, so that's what we're doing with this example here. Okay, so if you want to go 1 and it became 2 over 3, I multiplied by that. So here you're going to multiply by 2 over 3 as well. Okay, so think of it as you're going to go 2 moles and then you're going to multiply by 2 over 3 like that. So you'll end up with 4 over 3. Okay, and if you want to change that to a decimal, that becomes 1.33333 moles of ammonia. Okay, so it's a little trickier when there's different numbers here, but that's all you do. You write the first one. So the rule of thumb is write the first one that you know information about. So like the word problem will say you have 2 moles of hydrogen, okay? How many moles of ammonia do you need or will you produce, okay? So since we know that, we write this one first. We write the ratio in according to our balanced chemical equation here, 3 to 2. And then we want to get it dropped down to a ratio of 1 to something, okay? So we want to drop the one that we know down to 1. So I need to do that. I need to divide by 3 to get to 1. So I'll divide the other side. So now I know it's a 1 to 2 to 3 ratio. Okay, so if I have 2 moles, well, then I just need to multiply 2 over 3 to get to 1.3 moles of ammonia. All right, let's try the next one. So mole ratio of ammonia to hydrogen. So what if we, it reversed? So what if we know this one and we're trying to find hydrogen, okay? So now it's a 2 to 3 ratio like that. Okay, so same thing, we know ammonia. So we're going to find that, change that to a 1 to something ratio here. Okay, so we have, so I want to get this to 1. So in order to do that, I would have had to divide by 2. Okay, we're just trying to get our ratio. It's still the same ratio, but we're just trying to get it so it's a 1 to something ratio. So in this case here, I'm going to divide this by 2 as well. And then I end up with a 3 over 2 ratio. Okay. All right, so according to the balanced chemical equation, if you ended up forming ammonia, you would have a 2 to 3 ratio. So you would have needed 3 hydrogens to form the 2 ammonia. So if we reduce it down, it's a 1 to 3 over 2 ratio, or again, if you work better in decimals, you can change this to 1.5 like that. Okay, so for every 1 ammonia that you get, you had to use 1.5 hydrogens to form the ammonia. All right, so again, if we look at an example here, so let's just say we know that there's, I don't know, 14 moles of ammonia, okay? So if you know that there's 14 moles of ammonia, well, what's the relationship here? Well, you need 1.5 times the other one. So you know you're going to multiply by 1.5 here. Okay, so if you do that, 14 times 1.5 will become 21 moles of hydrogen. Okay, all right, so this is always the tricky part every year when I show this, so I just wanted to kind of have a separate little lesson for it where you are just practicing and understanding the concept of ratios, and if you know some information about like the first like I don't know compound here, can you predict what the other amount would be because using the mole ratio here? Okay, so just kind of review these notes and then practice some questions, and then I'm not going to have a checkpoint today because I want you to just get good at these, and then we're going to use it tomorrow.